We're on page 76 in your journal. There is no homework with this, but there is some things that we need to go over. So some of these are filled in, so you can go ahead and pause it and fill them in. Verbal statements can be changed to algebraic expressions. And so you're going to go from words to an algebraic expression, okay? So it's almost like translating one language to another. So you're going from symbols to words, or from words to symbols. This expression, an expression is a mathematical phrase that contains terms, operation signs, and constants. So we will learn what the parts are down here, okay? An expression does not contain an equal sign. All right, so an expression would be something like a plus 5 or b minus 6 or something like that. It does not contain an equal sign. An equation does contain an equal sign. All right, so it might have two expressions like this that are equivalent to each other. So this is an expression and this is an expression. But if there's an equal sign, then that means that that is an equation. So this right here, there's no equal sign. So this is going to be an expression. And the reason why is because there is no equal sign. This right here has an equal sign here, so that is going to be an equation. And the reason is because it does contain an equal sign. It's really that simple. So we have 17 minus 2, so 17 minus 2. There's no equal sign, sorry. So that's going to be an expression. And there is no equal sign. This one, no equal sign, so this is going to be an expression. And there's no equal sign. 5 times 10 is 50, so remember that is means equal, all right? So that's going to be an equation because there is an equal sign. And again, this is going to have an equal sign, so this is going to be an equation, and then it has an equal sign. So on the STAR test I've seen before is that they have they'll give you like all of these, for example, and they'll say, check the box beside 3 expressions. So you would go and you'd find 1, 2, 3 expressions, and you would check the box beside them. The other ones are equations, so you wouldn't check the box. So let's talk about the parts of an expression. All right, so we'll talk about this and then we'll use this vocabulary a lot later on in the week. So we have 4D, all right, the 4 right here, that's what it's pointing to, the 4. That's called a coefficient, okay? A coefficient is the number that's multiplied by the variable, the letter. Okay, this D right here, that is, replacing, or it's standing for a missing number, okay, for the unknown. So that is a variable. That's the letter. This, of course, is just a subtraction sign. So you're going to see a subtraction sign and an addition sign in between terms. Okay, so what a term is this is a term and this is a term. So there are 2 terms in this expression. This whole thing right here is called just an expression. We've been talking about those. This right here does not have a variable with it, so it is called a constant. Okay, so when we go over here, we're going to talk about algebra tiles a little bit, and we'll go more in depth on other days about this. But what this means is when you have a pile of blocks, what that really means is x plus x plus x plus 1 plus 1 plus 1. So you're just adding. So as you were counting when you were little, all you were doing was adding. So 1, 2, 3 is 1 plus 1 plus 1. So when you have 3 groups of x, I know that means multiply, but 1x plus 1x plus 1x is 3 groups of x. Okay, so that right there is 3 equal groups of x plus the extra 3. And we can't add these. We'll learn later on in the week that those are not like terms. So that's as simple as we can get that expression. So on this one, we've got 2 that stand for positive 1. We've got an x. So if there is no number in front of the x, we assume that there's an invisible 1. Okay, so you assume that there's an invisible 1. So there's one group of x in each of those. And then we've got 1. So if we wanted to write this another way, it would be 2x plus 3. So how would we draw this one? Well, if we had plus 1 was a positive 1, if we have minus 3, we can do a negative 1, and we can do it 3 times. So we have 2 groups of x, all right? And then we've got 3 negative 1s. So that's going to be the same as 2x plus negative 3. Okay, so remember when we combine these signs right here, we would get a negative. So that would be the same as that. So that really is x plus negative 1 plus negative 1 plus negative 1. All right, this one right here, if we drew it, we would have one group of x. We'd have 3 negatives. Okay, you're going to learn that negatives and subtract are pretty much the same motion on the number line. And then we've got 1x here. Okay, so if we combine these, we would have 2x minus 3, or we could write it like this right here. So when it says which expressions above are equivalent, this is equivalent to that. So it's going to be C and D, and it's because we have the same picture is how you would prove that those are equivalent to each other. All right, we're going to skip this, and we're going to skip that. 4 statements are given. Cross out the statement that is not equivalent to the rest. So we've got 50 plus 12. That's going to be 62. 50 plus 12 is 62. 50 plus 6 plus 6 is 62. All of those were expressions. This says 50 plus 12 is 62. So the only difference between this one, even though they're all 62, the only difference is that these here are expressions. And this right here is an equation. So that would kind of be the odd man out. That wouldn't match the others. All right, on this one, Carmen modeled an expression using algebra tiles, but part of her solution was erased. Find the missing part of her solution. So they have the 2x, the 2 groups of x, and so this part is the part that's missing. So I can say 2x plus negative 4, that's one way, or I can combine these 2 signs and just put minus 4. So on this one, a ticket to a trampoline park is priced at $6.50. When 3 friends purchase tickets, the expression $6.50 times 3 can be used to determine the total cost. What other expression can be used to determine the total cost? So yes, we could write 3 times $6.50. We could just change the order, but this is 3 equal groups of $6.50, so I could also write it as $6.50 plus $6.50 plus $6.50.